the strength of the gravitational force between two objects. In words, these equations state that the gravitational force between two bodies is proportional to the product of their masses. So as we said, product of the masses, GMM, right? MM as in two M's. One M for one object, another M for another object. And inversely proportional to the square of the distance between them. So GMM over R squared. That's the R squared is the distance between them. Okay? This law of gravity can be used to predict the motion of planets and comets around the sun, the moon about the earth, and rockets heading off for planetary explorations, as well as more earthbound applications such as baseballs flying through the air and divers spiraling poolward from springboards. The agreement between the predictions and the actual observed motion of such objects is spectacular. Spectacular. This success gave Newton's theory unequivocal support until the early part of the 20th century. So this law was good for freaking forever. In fact, it's still used. Even now, when we launch rockets and things like that, it's good to just do Newtonian mechanics. It's good to just get the equations and the mass R, all that stuff it's completely okay to still follow Newtonian mechanics and you will be good enough, right? So that is quite a feat that he gave us some law, some equation so long ago from the 1600s that's still working. So up to the 20th century, it was not only working, it was the law of the land. It was it. That was it. Like nobody knew any better than that. Absolutely nobody. Einstein's discovery of special relativity, however, raised what proved to be an insurmountable obstacle for Newton's theory. So it's not that Einstein came in and said everything about Newton's theory was wrong. It's just that Einstein came in and gave a more general description of gravitation where Newton's theory is correct for certain sizes, certain speeds and whatnot. After that, we need Einstein's theory, and so Newton's theory kind of becomes a subset of the more updated theory for gravitation, which is general theory of relativity. Okay. So that's this insurmountable obstacle. We will read more about that. But that's really what this is about. It's not that Newton's theory is completely wrong and just like never works or anything like that. We still use it. So it is still very much a thing and it still very much works. Hello. You flung your hair back and it landed in the same place. Yup. Batman, you will do better to just sit down and not talk. You're in a physics class? Colorado in the house? Are you from Colorado, Batman? I thought the people of Colorado knew better than to be this weird on my lives. Okay, so it's not that the Newtonian theory is completely wrong. In fact, it is still applicable in a large and very many scenarios, in pretty much all of our day-to-day scenarios and scales and sizes. But Einstein's general theory of relativity is the more general theory for gravitation. It's the more updated theory for gravitation, and Newtonian mechanics becomes sort of a subset of that. Okay, so that's what we will keep on going forward here. We'll read about, we will read about the incompatibility of Newtonian gravity and special relativity next. There is a few big concerns that special theory of relativity brings up with Newtonian gravity. So we will